And so in this example 8, you see that agricultural exports and imports. Over the past few decades, the United States has exported more agricultural products than it has imported, maintaining a positive balance of trade in this area. However, the trade balance fluctuated considerably during that period. The graph below approximates the rate of change of balance of trade over a 50-year period, where B of T is the balance of trade in billions and T is the time in years. So they're asking us to write a brief description of the graph of Y, including the discussion of the local extreme. So if you look carefully, you can see that in this case, the graph of the derivative contains the same essential information as the chart. This is that we see that there is a B of T is positive on 0, 4, and 0. At T is 4, you see a negative trend from 4 to 12, and at T is 12, there's a positive trend on 12, 15. So the trade balance increases for the first 4 years to a local maximum, and decreases for the next 8 years for the local to a local minimum, and then increases for the final 3 years. And you can see that from 12 to 15 on the X, going across the X. Part B is to sketch a possible graph. And so using the information that's given to us, we can actually see that we cannot produce an accurate graph. However, we can sketch a possible graph, which we can illustrate by taking the derivative. The absence of a scale value of the vertical axis is a consequence of the lack of information about the values. And so as we're looking at this, we can actually tell that at 12 we should have somewhat of a local minimum, and at 4 we are actually at a local maximum, and you can tell because of the fact that these are positive. So that's the gist of example 8. All right, example 9. If you look at this example, they start you off with a revenue analysis. And in this case, this is for the sale of bookcases. So you can see it's an upside down parabola, basically, with it looks like its maximum is close to 500. And it looks like, what would you argue that to be? Like maybe 30,000, or just slightly above for the axis, so vertical axis. So in this case, they want us to simply write a brief description of the graph of the marginal revenue function, where Y is equal to the first derivative of revenue, including a discussion of the intercepts. And then part B, they simply want you to sketch a graph.
Did I find him?
So in the description that they're providing, they're saying that the graph of Y equals Rx indicates that the function increases at 0, 550. 0, 550, and it has a local maximum at X is equal to 550. And then proceeds to decrease from 500 or 550 to 1000. Remember, we're looking along the X-axis only there. So consequently, the marginal revenue, which is the first derivative of revenue, must be positive.
Somewhere deep inside.
Of 0 to 550, it's going up, as you can see, left to right. At X is 550, and negative on 550 to 1000 as it's decreasing. That's a very simple explanation. The main gist here is that you get a grasp of the connection between the first derivative, which is the marginal revenue function in this example. In part B, they're asking you to sketch a possible graph. And so in this case, they give you a solution down here, which is quite interesting. If you notice, the possible graph of the first derivative, as summarized in part A, looks like it's going to decline from y, some value of y, as it decreases down to 550. You would take that from just the description of the graph. If it's a parabola, remember you're taking the first derivative, an upside down parabola at that. So just use a typical, parabola argument, which would be like negative x squared. And if it were to take the derivative, it would simply be 2x negative 2x, which hence will give you this type of shape. That question would not be, these questions would not be asked as such. I would not ask you to graph. So, on a test or on a final exam, I will not ask you those questions. This is just an FYI you should know, which is why I'm recording it for you. In example 9, we're looking at the total revenue R of X from the sales of X desks. So they're giving you a maximum at, let's say, 450, all the way up to, for X at 450, we're looking at, it looks like close to 60,000. And so they're asking you to write a brief description of the graph and then obviously sketch the graph. And so the description of this will be very similar to the discussion provided in 8. So you would say basically the same thing from 0 to, I guess, 450 on X. We would have an increase, and it looks like, so we would say it's increasing from 0 to 450. It does have a local maximum at X is approximately 450, and the Y value reaches approximately 60,000. I'm saying approximately because I don't see that is perfectly matched either. It does decrease from approximately 450 down to, it looks like 1,000. So very similar description as the prior one. In sketching the graph, I would not ask you to sketch the graph. And again, I'm recording this because this is something we will discuss in class and very briefly just talk about. There's really nothing to other than to describe and take away. That's it. So we're done with 4.1.